So you can use your pencil, but what I do with the smartboard is I grab a vertical line and then I grab a horizontal line and I draw those across, okay? Kind of like I had over here. I'm going to push those down here for a second. But when you look at the domain, we grab this vertical line. We start to drag it across. And I drag it across these x values, -6, -5, -4, -3. And I try to decide, will the graph have an output at those spots? For example, as I put it at -5 here, does the graph have an output? Yes, so therefore -5 counts as the domain. Does the graph have an output at 1? Yes. Will the graph have an output at -10? It will. It will continue on over there. Will it have an output at +10? So therefore, the domain is from -infinity to +infinity. Or x is all real numbers. You can write either or. For the range, okay, as we put it down here, I move at these -7, -6, -5. Will the graph cross this line? Yes. Does it cross here? Here? So therefore, the range in this situation is all real numbers. -infinity to +infinity, or y is equal to all real numbers. All polynomials have a domain of all real numbers. So if you see a parabola, that's a polynomial, it'll have a domain of all real numbers. As you can see, as you drag this vertical line across, the graph will have outputs wherever that vertical line goes. And so your domain will be all real numbers, or from -infinity to +infinity. You can write either or, it does not matter, folks. But for your range, what's different about the range? Starts at 0. A lot of people say it starts at -3. -3 is the x value. For range, we're wondering about the y value. You see that the lowest y value is 0. So we start at 0 and we move up towards infinity. So our range is from 0 to infinity. At no time do we have a y value that is negative. Is that clear? Let's look at a different one. Let's look at number 5. 5 is a little bit more difficult. I'm going to drag my vertical line across. Will this graph ever cross -6? No. -5. How about -4? In fact, there are only 2 values that are in the domain. What are those? -4 and +3. When you can actually list the values, you use what we call roster notation. The domain will be -4 and +3. You use those squigglies, okay? So that's a finite number of domain elements. We just have -4 and +3. However, if you look at the range, we are actually going to list 2 intervals. When's the first time that we catch this graph on the horizontal line? -5 to -2. And then we break. We pick it back up again and we go to 4. Okay? So Schaefer, you were right, 4. I'm going to start from the bottom, go up. So our range, we go from, as you said, -5 to -2. And we union that with 0 to 4. How's that? Let's try 2 more. Let's do number 11. Number 11, as you drag this vertical line across, is the graph going to cross this right now? Yeah, it will cross it, okay? Here it crosses it. It's going to cross over here. So what's the domain going to be? Yep, -infinity to +infinity, all real numbers. And then the range, yes. Yeah. No, you just write negative infinity, infinity. Yep. Come on. All right, there you go. Okay. But the range, when's the first time I pick up a value? 2, and then it goes till 5. So the range looks like it's going to be from 2 to 5. We can talk 6. Sure. Domain. When do we pick up the first domain value? Negative 5. And there's a break at what? But isn't the function still evaluated at 0? So I could continue on until 3. It's not a continuous graph. You have to pick up your pencil to draw it. But there's still, you can, if you plug in 0, you get a value. You get 6. So that's fine. The range, though, how many values do we have for the range? 2 distinct values. So therefore, we can list it in roster notation. These are distinct values. What are they? -3 and +6. I want to do one more with you. Flip it to the back side. And I apologize about number 20. My intention was that we would understand this just a little bit better. But 20, my intention was, and you can't really tell that necessarily from the graph, but is that it would be what we call a hyperbola graph. Hyperbolas are unique. We haven't really learned about them yet. You will. But where they don't quite touch an imaginary line. In this case, the imaginary line intended to be is right here, the y-axis, and then another imaginary line, the x-axis. So there are graphs like this that come close to touching a spot, but they don't actually ever cross over. Okay? For example, this would be the graph of y equals 1 over x. What number can't you have for x? 0. So you can see the graph never crosses that line of x equals 0. It can't. Furthermore, there's nothing you can plug in to get y to equal to 0, so it will never cross that part either. You don't have to really understand that right now. I just want you to understand that this type of graph is a little bit different. These do go on forever in these directions, but this one's unique. So what would the domain be here? Zero to infinity, and what would the range be? Or 0 infinity. Yeah. Always put the smaller number first. 0 to infinity. Okay? Parentheses because it never crosses 0 and you can't include infinity. All I want you to do is take your time and work through this. I want you to check your answers. I will have the answer key right up here by Emma, and Will. And that's it. Get out, support your teams tonight, tomorrow, next Saturday as people start to conclude their seasons, and enjoy just a little bit of a break tonight, okay? You guys work pretty hard. Be ready for harder work tomorrow and Friday, all right?